Hello everyone, and welcome. Today we're going to learn about two super useful tools that'll help us tidy up all those long, messy numbers you sometimes get in maths. It's all about making them neat and way easier to use.
So let's dive right in. Have you ever, typed something into your calculator and the answer that comes out just fills up the entire screen? I'm talking about a really, really long number with a ton of digits after the decimal point.
Yeah, exactly like this. Now, a number like this is super exact, which is cool, but in real life, and especially in your exams, you usually don't need all that detail. It's just messy. So what we need is a way to make it simpler, easier to work with. And that brings us to our first tool for the job. It's called significant figures. Just think of it as a way to find and keep only the most important digits in a number. So what even are they? Well, significant figures are basically the important digits that give a number its actual value. And here's the biggest rule you need to remember. You always start counting from the very first digit that is not a zero. We'll see exactly what that means in just a second. Right, so this brings up a really good question. What about zero? Is it important or not? Well, sometimes it is, and sometimes it isn't. I know, it sounds a little tricky, but don't worry. There are a few simple rules that make it super easy. And here they are, the 3 simple rules for our friend the zero. Let's go through them one by one. First, zeros at the start, not significant. Second, zeros in the middle, yep, they are significant. And third, zeros at the very end of a decimal, those are significant too. Okay, let's break these down with some examples so you can see what I mean. Okay, so rule number 1, zeros at the beginning of a number, they don't count as significant. Take a look at this example, 0.00900,364. See those first 3 zeros right at the start? They're basically just placeholders. They are not significant. That means our very first significant figure in this number is the 9. Now for rule number 2. Zeros that are kind of sandwiched between other non-zero digits, well, they are always significant. They're super important. So if we look at our number again, 0.00900,364, those 2 zeros right between the 9 and the 3, oh yeah, they definitely count. And finally, our last rule for zeros. When a zero is at the very end of a number, but after a decimal point, it is also significant. So check out this number, 50.760. That zero at the end is really important. Why? Well, it tells us that the number was measured to be exactly that value. Not 50.761, not 50.759. It shows us how precise the number is. So that final zero, it absolutely counts. Okay, great. So now that we know how to find the significant figures, how do we actually use them? Well, we use them to round numbers. This is where it gets really practical. And here is the golden rule of rounding that you've probably seen before. It's super simple. You just look at the digit that comes right after the one you want to keep. If that digit is 5 or more, you round up. Simple as that. All right, let's put this into practice and try one. We've got the number 50.7605. Our mission, should we choose to accept it, is to round this number to 3 significant figures. Let's do it. Okay, first step, let's find our first 3 significant figures. Starting from the left, that's the 5, then the 0, and then the 7. So 7 is the last significant figure we want to keep. Now, we just peek at the very next digit, which is a 6. So is 6 5 or more? Absolutely. And because that next digit was a 6, we've got to round up. So we add 1 to our last significant figure, which was the 7, and that turns it into an 8. And boom, there's our final, much tidier answer, 50.8. Fantastic. That was our first tool. Now let's move on to our second tool, which you'll be happy to hear is often a little bit simpler. It's called decimal places. And the definition for this one is pretty much exactly what it sounds like. When we talk about decimal places, we are only looking at the number of digits that come after the decimal point. Nice and easy. All right, let's try an example for this one too. We need to correct the number 745.9586 to 2 decimal places, or as you might see it written, 2dp. So the most important thing here is that we start counting after the decimal point. That's the key. So the first decimal place is the 9, and the second one is the 5. That 5 is the one we're focused on. Now let's look at the next digit over. It's an 8. Is 8 5 or more? You bet it is.
And since it's an 8, we use our same rounding rule. We add 1 to that 5. This turns our number into 745.96. See that? It's the exact same rounding rule. We just have a different starting point for where we count our digits.
So let's just put them side by side to make it super, super clear. For significant figures, remember, you start counting from the very first digit that isn't a 0. But for decimal places, you always start counting right after the decimal point. That is the one big difference you have to remember.
All right, I know that was a lot, but you've done an amazing job. Let's do a quick review of the main rules just to make sure this all sticks in our brains. Think of these as your rules for success.
Okay, let's lock this in. Remember, for significant figures, you always start from the first non-zero digit. Zeros in the middle, they always count. But those zeros at the very beginning, nope, they don't. And zeros at the end of a decimal, yes, they count too. Then you have decimal places, which is much simpler. Just start counting right after the decimal point. And the most important rule for both of them, the rounding rule never ever changes. If that next digit is 5 or more, you always round up. So, I'll leave you with this one final thought. We've learned how to round these numbers, but why do we even do it? When do you think a simpler rounded number is actually more useful in the real world than that super exact long one you get from the calculator? Give it some thought.
Thanks so much for joining me.